A. Without using any equation, define decay constant and half-life. Decay constant is defined as the probability that a radioactive nucleus will decay in 1 second. Half-life is defined as the time taken for a sample of radioactive nuclides disintegrate to half of initial number of nuclei. B. What is the isotope produced in each of the following radioactive decay? B1. Pb decays into uranium by emitting an alpha particle. B2. Na decays into magnesium by emitting a beta minus particle. And 3. O decays into nitrogen as particle. B1. Alpha decay. Alpha also identical as helium-4 based on the question Pb 23994 decay to uranium plus helium. B2 is beta minus decay. Beta minus particle identical also as E0 negative based on the question Na decay into magnesium plus beta minus particle for B3 beta plus decay. Beta plus particle identical also as 1 based on the question decay into nitrogen plus beta plus particle C. The activity of a radioisotope sample is 12 m-curie after 5 hours. The activity is 9 m-curie. Given 1 curie is equal to 3.7 exponent 10 b-curie. Calculate the decay constant, half-life, initial number of nuclei in the sample, and activity of the sample after 30 hours. Question given: activity A naught is equal to 12 m-curie. Activity A is equal to 9 m-curie. The time 5 hours or equal to in second. For C1, calculate the decay constant. This is decay constant symbol. To find decay constant, use the formula A is equal to A naught exponent negative T decay constant. Substitute all the given value in the formula. Use time, use in second or in hours. Use in second. Learn both sides. Decay constant, you will get 1.6 exponent negative 5 per second, or if you use time in hours, you will get 5.75 exponent per hour. Calculate half-life. Use the formula half-life is equal to ln 2 over decay constant. Use decay constant that we get from C1, either 1.6 exponent negative 5 per second or 5.75 exponent negative 2 per hour. But since the time given in this question is in hour, so we use decay constant per hour. So substitute. We'll get half-life equal to 12.05 hours. Change to second, we'll get 43380 seconds. C3. Calculate the initial number of nuclei in the sample. Initial number of nuclei in the sample is n naught. To find n naught, use the formula A naught is equal to decay constant n naught. The A naught given is 12 ampere. So, by using the unit conversion given, change A naught to decay per second. 12 ampere times with 3.7 exponent 10, you will get A naught 4.44 exponent 10 decay per second. Since we use A naught, we change to decay per second, use decay constant in second, which is 1.6 exponent negative 5 per second. Substitute in the formula of A naught equal to decay constant n naught. Substitute. You will get n naught equal to 2.7 exponent 30 nuclei. C4. Calculate the activity of the sample after 30 hours. Given time 30 hours. Use the formula A is equal to A naught exponent negative T decay constant as the question asks to find A. Use the same A naught, which is 12 millicurie, and use, since the times given is in hours, use decay constant 5.75 exponent negative 2 per hour, or change time into second and use the decay constant in second. But we use, in this question, we use in hours. So just substitute. You will get A naught, you will get 2.14. Carbon-14 with half-life of 5,730 years is used to date a bone found at an archaeological excavation. If the ratio of 14 carbon to 12 carbon atoms of the bone is 3.25 exponent negative 13, how old is the bone? The ratio of 14 carbon to 12 carbon atoms in living matter is 1.3 exponent negative 12. Given half-life equal to 5,730 years, Given the ratio for bone, ratio number of carbon 14 to the number of 12 carbon is 3.25 exponent negative 13. And for living matter, number of 14 carbon to number of 12 carbon is equal to 1.3 exponent negative 12. So use the formula n is equal to n naught exponent negative t decay constant. As we have two ratio, for the n naught is living matter and for the n is bone, as n naught is the initial. First, find the decay constant. Use half-life formula. Get decay constant 1.21 exponent negative 4. This is per year. Substitute in this formula to find time. Usual, loan both sides. So you will get T is 11.11457 years.